key speaker Antoine Despojuls from AFIM. He will show us which standardization bodies and produce general and multi-sector maintenance standards, and then how to show how predictive maintenance fits into the other maintenance types.
Okay, so Marco, may I have the control of the slide or not, or is it difficult? I don't know. In that case, you can click.
Yes.
Okay, thank you. I would like to tell you about the general maintenance standards and to give you a point of view on the positioning of predictive maintenance among the other maintenance types, which are defined in these different standards. So, as you can see on this slide, the standardization body involved in maintenance standards are at different levels. We have first the international level with IEC and ISO. Could you click, please? Yes, we have at IEC, we have the TC56, which is working on dependability. And we at ISO, we have more specific TCs working on specific maintenance techniques as mechanical vibration, shock and monitoring, condition monitoring. This is a TC108 and the TC135 about non-destructive examination. And we also have the TC251, which is working on asset management, and asset management consider that maintenance is a part of its area. It's like dependability. In fact, maintenance is both, let's say, concerned by competitiveness, which is more the asset management, and which it is also concerned by the risk, and this is more focused by the dependability standards. So now at the European level, we have, can you click please? We have the TC319, which is dedicated to maintenance. And the next level is at the national level. Every country has its national standardization institute. And in some case, we have some maintenance committee. It is the case in Germany, in Italy, in France with AFNOR. So we have sometimes some national maintenance standards which are produced by these bodies. So in fact, we have general and multi-sectoral standards, which are mainly coming from these standardization bodies. So next slide, please. Yes, the next. So at CEN TC319, we have recently developed this figure to show the published standards, and we have organized them in 4 parts. We have the first bases, which are of course terminology, and we have the standards which describe in detail the maintenance processes. Then we have some standards about management, about resources, about methodologies and practices. I am not going to quote all of them, but I think some of them have already been mentioned before. Especially we have the KPI, we have the risk-based inspection, for example, etc. So the next slide, please. Yes, we have also the IEC and ISO standards. At IEC, the TC56 published standards about dependability terminology, where we find some very interesting definition about maintainability, about reliability, which are quite useful in maintenance. We have standards about maintainability, about reliability-centered maintenance, RCM, about ILS, integrated logistics support, spare part provisioning, and so on. And we also have some very interesting reliability standards, as the famous FMECA, as root cause analysis, as fault tree analysis, and other kind of techniques, as Petrinet, etc. We also have at ISO, as I said before, and they were mentioned before also, some important standards about condition monitoring, about prognostic and diagnostic, and some oil and gas industry standards about reliability and maintenance data, which are quite general and interesting also. And from the TC 251, we have this ISO 55000 series about asset management. So there are also some standards from other more sectoral bodies, as SAE, which is the Society of Automotive Engineers, for example. It's just an example, but they have a famous standards about RCM. Therefore, there are many general standards on maintenance, maintenance methods, maintenance techniques, maintenance resources, and of course, I am not talking about more specific standards that may concern more especially predictive maintenance, and which were mentioned before as the standards about data models and communication protocols as Mimosa, etc. I am not an expert of these standards, but predictive maintenance is also quite concerned by these general standards, because predictive maintenance interact with the other type of maintenance, and it is of course a part of the maintenance strategies. So the next slide, please. So now I would like to remind you the different type of maintenance task to discuss the context and the position of predictive maintenance according more especially to the CEN standards, and especially to the EN 13306, which is the terminology standards at CEN. And for that, I like to use this figure showing the evolution over the time in the performance of an item that degrades and eventually fails. I have only represented here a slow and gradual loss of performance, but of course we can have also a sudden or complete degradation of the performance. But in any case, we need to define an acceptability threshold. Can you click, please? In order to define the up state and the down state. The crossing of this acceptability threshold defines the failure. And now we can define different kind of task. Sorry, the color changed, so it is not really readable. But after the failure, when we are in down state, we will find the task to restore the item into a state it can perform the required function. Of course, it is the corrective maintenance task. And before the failure, when we are still in up state, we can perform some task to restore the item into a state which is where it is in better condition, let's say. So this task can be based on time or on unit of use, or they can also be triggered by observations, which are the third kind of task. If you can click one more, we have also this task to observe and analyze, and predictive maintenance will be concerned by this kind of task, of course. Next slide, please. So to define and to select these tasks, we must consider the context, which is shown on this general maintenance model. So first, the item is, let's say, as good as new. It is in sound state. And due to failure mechanisms or other kind of failure, like non-quality in maintenance, for example, or a bad manufacturing, the item will degrade. it will be in a degraded state, which means that it is still above the acceptability threshold. But if nothing is done, then failure modes will happen, and the item will be faulty, and that will lead to plant effect in terms of availability, cost, safety, etc. Of course, we have also to complete this model to take into account the fact that the faulty and degraded item can become influencing factors which can induce failure mechanisms. Failure mechanisms are the diseases of the items that can be corrosion, erosion, fatigue, etc. And they are influenced by some operating modes or environmental condition that must be taken into account. So to avoid this bad evolution of the item, we can define some maintenance task. Can you click, please? Yes. So we can define some condition-based maintenance task. If we take into account the degradation, we can observe the degradation or sometimes the symptoms of the degradation, or we can perform some predetermined maintenance tasks which are triggered by a number of units of use, or when the item is faulty, of course, we have corrective maintenance tasks, and it is also possible to perform some improvement to modify the dependability characteristics, the reliability and maintainability of the items. These maintenance tasks make it possible to restore the item is in good condition, but of course they have also some effect on the availability, cost, safety sometimes. And predictive maintenance is in fact a part of the condition-based maintenance, which is also a part of preventive maintenance. I am going to explain a little bit more this point. Please, the next slide. So to precise the preventive maintenance task, we have first the predetermined maintenance tasks, which are tasks without observation, based on a calendar time or a number of units of use, kilometers, for example, for a car. We are going to apply immediately the active preventive maintenance action. Another way is to use condition-based maintenance and to do some observation of the degradation of the symptoms or of the influencing factors according generally to a calendar time, a number of units of use hours that can be done continuously. And based on this observation, there is a diagnosis which is done on the diagnosis of the actual state of the item, and either everything is okay, so there is no action, either we are above a given threshold, and in that case, active preventive maintenance action is performed. Please, the next. Yes, we can also perform some more advanced techniques to make a prognosis, a prediction of the degradation evolution and a calculation of the remaining useful life, and that will make it possible to determine a date to perform the active preventive maintenance action. This is predictive maintenance. So this slide from the standards EN 13306 show the place of predictive maintenance. And I think in the future, we can think that the progress which are made in predictive maintenance techniques will make them more and more competitive, and probably predictive maintenance will become more important among the other kind of tasks. So the next slide, please. There is another view, another presentation of the maintenance from the EN 13206, which show which tasks are scheduled and which tasks are unscheduled. The scheduled tasks are, of course, the predetermined maintenance tasks, which are done without any observation, but there are also observations which are scheduled. The observations which are made by condition-based maintenance tasks. And we can also have some corrective maintenance tasks, which can be scheduled also if they can be deferred. This is the deferred corrective maintenance task. If we look at the unscheduled maintenance task, now we have, of course, immediate corrective maintenance, which must be done just after the failure. And we have another category, which are called opportunistic maintenance, and which can be preventive or deferred corrective maintenance tasks. These are the tasks undertaken at the same time as other maintenance actions or particular events in order to reduce the cost, to reduce the unavailability, etc., and to optimize. So I think that, you can click the last time, I think that the predictive maintenance task is very suitable for determining the actual state of an item, and then to allow a maintenance strategy, including opportunistic maintenance and optimizing availability and cost. So possibly in the future, more and more using predictive maintenance, maintenance strategy could shift from scheduled maintenance to more opportunistic maintenance in order to improve the cost, the availability, and making the right task at the right time. So I think this is a vision of maybe in the future